In class activity 12D, here comes the sun. An architect is designing a building that will include solar panels on the roof. What are some of the considerations the architect might consider in positioning the building and the solar panels? Well, there's various answers that we could suppose here, but the architect will want to position the solar panels so that the panels capture as much sunlight as possible. The position will vary depending on the latitude of the location, the presence of nearby buildings, the slope of the roof, and so forth. So let's go to this next screen. Objectives for the activity. You will understand that there is more than one method for finding the unknown angles in a triangle when all three sides are known. You will be able to find the missing angles in a triangle when all three sides are known. 2, after considering various factors, the architect decided that it would be best for the roof of the building to have an asymmetric triangular shape, as sketched in the diagram shown. The architect sends the sketch to a manufacturer to create a set of roof trusses. To build the trusses, the manufacturer must determine the angles at A, B, and C. Part A, first use the law of cosines to find the largest angle. Let me scroll this up here. There's the picture. So it looks, just from the picture, it looks like angle B is going to be the largest angle. So I am going to use the law of cosines. Just one second here. There we go, the law of cosines in this form. B squared equals A squared plus C squared minus 2AC times the cosine of angle B. And I'm going to rearrange this a bit. I'm going to leave the B squared where it is on the left for now at least, and then write A squared minus, and then a minus C squared. And this is equal to negative 2AC cosine of B. Then if I divide by the coefficients of the cosine of B, we're going to have B squared minus A squared minus C squared. That's supposed to be C squared. Let me write C. There we go. And that's over negative 2AC. And that's still equal to the cosine of B right here. I'm going to use the arc cosine. So let me extend the page here. And I'm going to write the arc cosine of, and I'm going to get rid of some of the negative signs. So I'm just going to multiply through that left side of the equation by a negative. And when we do, we get A squared plus C squared minus B squared over 2AC. And that's going to be equal to angle B. So if we start plugging in some of the numbers here that are given to us, and these are the numbers, I'm going to scroll back up to the picture here, that are given to us, the 11, the 19, the 24, the lengths of the sides of the triangle. So if we do that, we have the cosine, or the arc cosine, excuse me, of 11 squared plus 19 squared minus 24 squared. And that is going to be over 2 times 11 times 19. This is still going to be equal to the angle B. And when we plug this into our calculator, we're going to come up with B is equal to, I get 102.9958, and it goes on, but degrees. And I'm going to use B is about, it's pretty close to 103. So I'm just going to use 103 degrees. And 103, I'm going to go ahead and put this on my picture here. 103 degrees. So that's part A. Part B is here. It says use the law of sines to find a second angle. So we can use the law of sines at this point, which is A over the sine of A equals B over sine B. So if I plug some of these numbers in, A is 11. The sine of A, we don't know what angle A is yet, so we just definitely don't know the sine of A. B is 24, and now we know the sine of B, which is sine of 103 degrees. Okay, I'm going to solve this for the sine of A, and that's going to be equal to 11 times the sine of 103 degrees over 24. And then that means that we can take the arc sine of 11 sine 103 over 24. And when we do this, we're going to find out this is going to give us angle A. So angle A is equal to 26.5 degrees. So angle A is 26.5. Let me go back here, and put that on the picture. And part C, I bet you is coming next. Yeah, find the remaining angle. Well, for this, we can take 180 minus 103 minus 26.5. And when we do these subtractions, we get 50.5 degrees. And that is angle C, which is back here. There we go. So there's B and there's C. So let's go to the next screen. Part 3, it says the steps given in question 2 are only one way of finding the 3 angles of a triangle. When the 3 sides are given, decide whether each of the following statements is true or false. Part A, it would have been impossible to use the law of sines to find the first angle. Part A is false. Part B, it was not necessary to find the largest angle first. Instead, one could have started by using the law of cosines to find one of the acute angles. That is true. Part C, it would have been impossible to find the second angle by using the law of cosines. Part C is true. Part D, it would have been possible to find the third angle by using the law of sines. Part D, true. Part E, it would have been possible to find the third angle by using the law of cosines. Another true there. And that's all that's there. So let's go to the next screen. When finding the missing angles of a triangle whose 3 sides are known, it is generally most efficient to 1, check that the 3 given sides satisfy the triangle inequality, and then 2, follow the steps outlined in question 2. Part number 4, solve the triangle ABC when the sides are A is equal to 7, B 15, and C is 24. Well, I'm going to use go through the same routine that we've been doing. And we've done this already, so we don't have to write everything over again and develop it. We can take the arc cosine of A squared plus C squared minus B squared. And that's all over 2AC. And remember, this is going to give us angle B. Whenever we use the arc functions, that's going to return an angle. So in this case, it's going to be angle B. So let's go ahead and substitute in some numbers. So A is 7, so we're going to take 7 squared plus C is 24. That's squared, minus B is 15, so we have 15 squared. And that's all over 2 times A, which means 7, times C, which is 24. And this will be B again. So if we put this into our calculator, you're going to see you're going to get some kind of error message, or it might say undefined. So it is not possible to have a triangle with these side lengths. Next screen, number 5. Solve the triangle ABC, where A is 23, B is 14, C is 21. So we could do the same routine. I'm going to start this with the arc cosine And I'm going to go ahead and plug in these numbers. We have 23, that's squared, plus 21 squared minus 14 squared over 2 times 23 times 21. And this is going to give us B. So angle B, if we plug this in, gives us about 36. I'm going to round that up to 0.8. And that's going to be degrees. Now we could use the law of cosines again, but we could maybe easier to use the law of sines. So let's do this. Let's take this B over sine B. A, it's supposed to be an A. Let me draw a better A than that. A over sine of A. So we're going to get 14 over the sine of, we just found this, 36.8 degrees equals 23. And we don't know what sine of A is yet. But if we solve for the sine of A, we're going to get 23 times the sine of 36.8 degrees all over 14. So that means that we're going to take the arc sine of that ratio that we just wrote, 23 sine 36.8 degrees. That's going to be over 14. And this is going to return A is about 79.8 degrees. And from here, we could just subtract what we found, the 36.8 and the 79.8 from 180. And we are going to end up with what we found A and we found B. So angle C from 180 is going to be 63.8 degrees. And that's the end of this video. Thank you.